Welcome, ladies and gentlemen. Today we're going to start polynomials. So we're going to talk about polynomial vocab, polynomial operations, and synthetic substitution. All right, here we go. Types of polynomials. Oh, you guys, make sure you have your guided notes, or else you're going to have to write down a lot more, okay, than I want you to. All right, different types of polynomials. First one is one term. It's called the monomial. It is a number, a variable, or a product of a number and one or more variables with whole number exponents. That's really important. So that's like 1, 2, 3 are counting numbers, okay? Here's some examples of that. So 8, negative 2 times x, 3 times x squared times y, 1/2 x squared. Then we have two terms, which is called a binomial. So like x to the 4th minus 8. We have two terms. Then we have three terms called a trinomial. Now each term is put together with an addition or subtraction sign. Okay, that's how we separate our terms. And then we have more than three terms, which is called a polynomial. So like this one is 3x to the 5th minus 2x cubed minus 5x plus 4. So it has to have more than three terms. All right, moving on. A few more definitions. Standard form is going to be written in largest to smallest exponent. So we start with our largest exponent and we go down to our smallest. The degree is the largest exponent. That's our degree. So you have this table. These are degree and types. You find your degree and that tells you what type it is. So we have degrees 0, 1, 2, 3, and 4. 0 will be a constant, so it's just like a number. Linear is going to be like 5x minus 7. A quadratic is going to have an x squared. A cubic function is going to have an x cubed. And a quartic function is going to have an x to the 4th power. All right? So we have to decide if a function is a polynomial. If so, we have to write it in standard form. State the degree, type, and leading coefficient. Remember, to be a polynomial, all of our exponents have to be whole counting numbers. So if we look at this first example, this is what we have. Standard form, we have to write it from our largest exponent to our smallest one. So here's our largest exponent. So we put x to the 4th minus 1/4 x squared plus 3. Large exponent to nothing with to whatever doesn't have a variable. Sorry. The degree is the largest exponent. So our degree is 4. Now if you look back at that last note, we go to the degree and that table and we go over and we're like, okay, our type then would be quartic. Now, the leading coefficient, after we have it in standard form, the leading coefficient is what's right here. The number in front, the very front after it's in standard form. So in our case, there's nothing there, so our leading coefficient is just 1. All right, moving on. Second one, we want to know if this first is a polynomial. That's the first thing we have to decide. So all of our exponents have to be positive whole numbers. So 1, 2, 3, 4. If we look at this, our first exponent is negative 2. So this is not a polynomial. And it's not a polynomial because of this right here. Can't be negative. Okay, we cannot have negative exponents and have it be a polynomial. So this is not a polynomial. All right, moving on, ladies and gentlemen. Adding and subtracting polynomials. All right, I'm just going to show you how to subtract one because they're very simple. We've done this before. If we have subtraction, we have to change all of our signs. So this has to turn into a plus, and a plus, and now all we do is combine like terms. So here I have a negative 2x cubed and a positive 2x cubed, so those are just going to cancel out. Then I have to look, okay, here's an x squared. That's the only one, so I'm going to write that down because we want to write it in standard form from largest exponent to the smallest one. And then I check, and there we go. I have 4 and 8, so that's a positive 12. And that is all we have to do there. That's it. So it's very similar to what we've already done. Just a little summary, when we add and subtract polynomials, you need to have like terms. So if you want to write that down, this is not written in your notes, so you might want to write this down. When we add and subtract polynomials, you need to have like terms. Alright, multiplying polynomials. You guys, this is also really nothing new. I'm just going to go over one with you. Looks like this. All we're going to do, you guys, is a lot of distributing. We're going to distribute x to each one of these. So x times 7, we're going to get 7x. X times 3x, we're going to get plus 3x squared. X times a negative x squared, we're going to get negative x cubed. Now we have to do the same thing with 4. 4 times 7. 4 times 7 is 28, so plus 28. 4 times 3x, we're going to get plus 12x. And 4 times a negative 2x squared, we're going to get negative 4x squared. Now what we're going to do is combine like terms, starting with our largest exponent. So cubed is our largest, so I'll write that first. So negative x cubed. Then I have squared. I have this one and this one. So 3 minus 4x is 3x squared minus 4x squared is negative x squared. And then I need to do my x's, so I have 7x and a plus 12x, so I have plus 19x. And then last but not least, my whole number, so I have plus 28. So that is our answers, ladies and gentlemen. So we have to do a lot of distributing, and then we have to combine our like terms. So in summary, to multiply polynomials, you need to use the distributive property. So you might want to get this down. This is not in your guided notes, so make sure you write that down. We need to use the distributive property here. All right, ladies and gentlemen, all of this is already written in your notes. I'm just going to go through each one of these with you guys. So this first one here, x squared plus 3x minus 4. This is an expression. There's no equal signs. When we have an expression, all we can do is simplify a factor, but we can't solve it. Now, when we have an equal sign, so this next one right here, we have an equal sign, then we can use it to graph or to solve. Now, what we're going to talk about today is right here. This, what you guys don't like, this f of x. It's going to be huge in this chapter. We're going to use it a lot. Okay? It's just function notation. All it is a letter that names the equation. So we're not using y anymore. We're always going to use f of x or g of x or h of x. They all mean the same thing. Okay, ladies and gentlemen? All right, this is not in your notes. Don't put it in your notes. I'm just going to give you a little heads up of what we're going to do. There's 2 ways to substitute. One's direct substitution, which we've been doing forever, and our new way is synthetic substitution. All right, here we go. So direct substitution, if I give you this, evaluate f of x, which is 2x to the 4th minus 5x cubed minus 4x plus 8 when x equals 3. All that means is anywhere there's an x, I'm going to plug in 3. Okay, so I'm plugging in 3 anywhere there's an x. Now I'm just going to solve. So I get f of 3 equals 2 times 81 minus 3 cubed is 27 minus 4 times 3 is 12 plus 8. Then I'm going to simplify some more, and I'm going to get f cubed equals 162 minus 135 minus 12 plus 8. And then we would type this all into our calculator, and we would figure that f of 3 is 23. Okay, that is one way we can use substitution. The new way is called synthetic substitution. This is what we're going to learn. It's really awesome. It makes things really fast, and I love it. Okay? Biggest thing I want you guys to see is here's our problem. Same as the last one, and we're going to create this right here. This is what we're going to create every time we use synthetic substitution. Alright, so we know we need to evaluate when x is 3. So right here I want you to put x equals 3. Now it's very, very important when we do this that we fill in each one of these. So x to the 4th, what exponent's in front of that? Well, it's 2, so we're going to put a 2 underneath that. X to the 3rd has a negative 5 in front of it. X squared, if you look at this, ladies and gentlemen, there is no x squared. So we have to put in 0. If there's not an x squared here, we just put in 0 in front of it. And then we have an x, so we're going to put in negative 4. And no x, so we're going to put in, there's no x with this one, we're going to put in 8. Now, after we do all of that, we have to add these together. So we're going to put a big addition sign because that's what we're going to be doing. And do you see this arrow? This is very important. The arrow means you have to drop that first number. So our first number is 2. Put that down there. Now what we do with that 2 is we're going to take this number right here, what x equals. We're going to say 3 times 2. Well, 3 times 2 is 6. So we're going to put that over in our other column. We're going to write down 6. And we're going to take negative 5 plus 6, which is 1. Now, again, we're going to take 3 times 1, which is 3. Put it right there in our next column. 0 plus 3 is just 3. Again, we're going to take 3 times 3, which is 9. Now, we're going to take negative 4 plus 9, and we're going to get 5. Now, here, we're going to take 3 times 5, and 3 times 5 is 15. We add 8 and 15, and we're going to get 23. Okay? When we end here, this beautiful little cloud lets us know that's our answer. So f to 3 is 23. And that is our answer. We're going to do one more like this. We're going to set it all up, and then we're done. So we have to evaluate this when x equals negative 1. So we have to go through and set up the whole thing. So first thing, draw this. I need to know my x is going to equal negative 1. I start with x to the 4th, so that's what I write down first. X to the 4th, then I have to x cubed, and then x squared, then x, and then no x. And I have to put something under each one of these. So in front of x to the 4th, I have a negative 2. In front of x cubed, I have a negative 1. I don't have an x squared, so I'm going to put in 0. In front of my x, I have 4. And then in no x, I have a negative 5. So I'm going to put that down. Now to get this started, very, very important, we're going to be adding, and you have to drop it. Drop that first one. So we just drop it right down, and it's negative 2. Now we can get started. Negative 1 times a negative 2 is a positive 2. Negative 1 plus 2 is 1. Negative 1 times 1 is a negative 1. If I take 0 plus a negative 1, I get negative 1. Negative 1 times negative 1 is 1. And then 4 plus 1 is 5. And negative 1 times 5 is a negative 5. Add those together, and I get, because this is where my answer is going to be, negative 10. So just to finish it off, to solve it, I have g of x. So when x is -1, my answer is going to be -10. All right, ladies and gentlemen. Oh, the bell has just cut us off. It is time to be done. I hope that you have a wonderful, fabulous rest of your day. Thanks for watching, and I'll see you later.